students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is number-based system. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this topic, this lesson is for you. Lesson 6, conversion of fraction in base 10 to any other base. One method here is continuous multiplication. Continuous multiplication by the intended base, that is the base you want to convert to, until the final result is 0. You keep on multiplying until you get 0 in the final result. Examples: express the following decimals to decimals. Decimals means base 2. The instruction for now is to convert from base 10 to base 2. Example 28. We have 3/8. We should convert this number. The number is a fraction from base 10 to base 2. The first method, to apply it, you need to change the proper fraction to decimal fraction. So when you divide 3 by 8, you have 0.375. So this number, you keep on multiplying it by 2 until the last result is 0. As you are doing that, you also record the remainder as well. We multiply the non-zero digit part by base 2 continuously until the last result is 0. So if you multiply 375 by 2, you have 750. The remainder is 0. 2 times 5 is 10. Put that 0, you carry 1. 3 times 7 is 14. Plus that 1, you carry 15. Put that 5, carry 1 to 3. 2 times 3 is 6. Plus that 1, you carry 7. So you see why the remainder is 0. If you multiply 750 by 2 again, you have 500, and the remainder is 1. If you multiply 500 by 2, of course you have 0, 0, 0. The remainder is 1. Now when you watch very well, it is possible to write the 1 here, but we did not, because we are maintaining the 3 decimal places in the given question or true. So once you have the 3dp, every other number becomes a remainder. So starting from 0 point, your answer becomes 0.01 and 1 in base 2. So thus 3/8 in base 10 is equal to 0.011 in base 2. Hello. Example number 29, we have 27 over 32 in base 10. Convert it to base 2. The second method is to convert both numbers to base 2 and divide the result. You know, when you are converting from base 10 to a lower base, the procedure is continuous long division. We have talked about this in one of the previous lessons. So you have 27, you divide it by base 2, then you record your remainder. So you have 27 divided by 2, you have 13 remainder 1. You divide 13 by 2, you have 6 remainder 1. Divide 6 by 2, you have 3 remainder 0. Divide 3 by 2, you have 1 remainder 1. Divide 1 by 2, that is cannot, which implies 0 remainder 1. You record your answer upward in the remainders column. This is what this arrow stands for. So 27 in base 10 is equal to 11011 in base 2. You take the second number, that is 32, and carry out the same operation. You divide by 2 continuously until the quotient is 0. You can see that when we have 0 here, we stop division. So same thing here, 32 divided by 2, you have 16 remainder 0. Divide 16 by 2, 8 remainder 0. Divide 8 by 2, 4 remainder 0. Divide 4 by 2, you have 2 remainder 0. Divide 2 by 2, you have 1 remainder 0. Divide 1 by 2, you have 0 remainder 1. The quotient is 0. You stop division and you record the answer upward, such that 32 base 10 is equal to 1 0 0 0 0 and 0 in base 2. What it means is that 27 divided by 32 in base 10 is simply the result for 27 in base 2, 11011, divide by the result for 32 in base 2, 100000. When you divide, you have 0.11011 in base 2. When we get to operations with base number system, we are going to explain more about this. But for now, this is the result that you get when you divide. Example 30, convert 0.0625 base 10 to base 2. We are using the first method of continuous multiplication until the last result is 0 or true. Note that you only multiply the digits after the point, while you record your remainder under the first digit, that is 0. So you multiply 0.625 by 2, you have 1250. The remainder is 0. This is what happened. You have 2 times 5 is 10. Put down 0, carry 1. 2 times 2 is 4, plus that 1 you carried, you have 5. 2 times 6 is 12. Pull down 2, carry 1. 2 times 0 is 0, plus that 1 you carry, you have 1. That is 1, 2, 5, 0. Nothing is left, so you record 0. You multiply 1, 2, 5, 0 by 2, and you have 2, 5, 0, 0. The remainder is 0. You multiply 2, 5, 0, 0 by 2, you have 5, 0, 0, 0. The remainder is 0. You multiply 5, 0, 0, 0 by 2, you have 0, 0, 0. The remainder is 1. Note that this 1 could be here, but we are maintaining 4 decimal places, 4 decimal numbers after the point from the given problem. So once you have written 4 digits, whether 0 or any other digit, you write the remainder under the first digit before the point here. So you record your answer starting from 0 point, followed by 0, you have 0, another 0, then 1. So thus 0.0625 base 10 is equal to 0.0001 base 2. This is a continuous multiplication until your final result is 0. Example 31. Convert 3/8 in base 10 to base 2. We've done this one before, but we want to use method 3 to solve it again and see what we have. What we do here is that we split 3/8, precisely the numerator, into simpler number, and that is 2/8 plus 1/8, which we write as 2/8, 1/8. If you reduce 2/8, you have 1/4, 1/8. In this method, one thing you must ensure is that the numerator is 1. That is why we are splitting 3, we consider 1. Then we know if you add 2 to 1, you have 3. Then you reduce 2/8 to ensure that the numerator is 1. You express 4 and 8 in base 2. 4 is 2 square, so you have 1/2 square, and 8 is 2 cube, you have 1/2 cube. When you express in terms of power, if you take 2 power 2 up, the power changes from positive to negative. Same thing happens to 2 cube. So 1/2 square becomes 2 to the power of minus 2. 1/2 cube becomes 2 to the power of minus 3. This is what happened next. Thus, digit 1 represents a valuable exponent of 2 and 0 whenever it is absent. That is, when it is not present. This is what happened now. This 2 power of minus 2, 2 power of minus 3, we are supposed to start it from 2 to the power of minus 1 in that order. So you start from power of minus 1, power of minus 2, power of minus 3. So we write it in that order. But if you look at what we have here, power of minus 1 is not there. So where it is not available, you put digit 0 to represent 2 to the power of minus 1. In our result, 2 to the power of minus 2 is there. You use 1 to represent it. 2 to the power of minus 3 is there. You use 1 to represent it. Therefore, 3 over 8 is equal to 0.011 in base 2. So this is the third method that you can use. Hello. Example 32, convert 45.375 base 10 to base 3. We have a new instruction now. The previous examples was from base 10 to base 2, now to base 3. So this number has two parts, the whole number and the fractional part. So here you convert the whole number in base 10 to base 3. The method to be used here in converting the whole number part is continuous division until the quotient is 0. While the decimal part we use a continuous multiplication until the last result is 0 as well, or we have a repetition of pattern. So let's convert 45 to base 3. So this is the order. You have base 3 column, 45 column, and the remainder column. So you have 45 divided by 3, 15, remainder 0. Divide 15 by 3, you have 5, remainder 0. Divide 5 by 3, you have 1, remainder 2. Divide 1 by 3 cannot, which means 0, remainder 1. So the answer is 1, 2, 0, 0 in base 2. So you keep that answer. Then we'll come here and convert the fractional part. If you remove 45 from where it is now, what you have is 0.375. Remember, it is the digits after the point that you multiply continuously and you record the remainder under 0. So if you multiply 375 by 3, you have 125, remainder 1. If you multiply 125 by 3, you have 375, remainder 0. Remainder 0. If you multiply 375 by 3, you have 125, remainder 1. If you multiply 125 by 3, you have 375, remainder 0. Here you will observe that the process is repeating. You can see from 375 to 125, back to 375, back to 125. So once the process is repeating like this, there is no need to continue, because we have the same result, 1 0 1 0 1 0. So there is no ending to it. Once you observe that a pattern is repeating, is an indication that you need to stop the multiplication process. Okay, so remember 0 here, what should be in this place is 45. So the result for 45 now is 1200. That is the result we obtain from here. We have points, while the result for the decimal part is 1010, or in base 3. Hello. Example 33, we have 1196 whole number, 178 over 256 in base 10 to base 16. We take the same approach here, where you convert the whole number parts to base 16 by continuous long division, and you convert the fractional part to base 16 also by continuous multiplication until the last result is 0. So let's take for the whole number part, that is 1196. This is a column for base 16 and this is a column for remainder. If you divide 1196 by 16, you have 74, remainder 12. You know 12 implies C in base 16. Remember, divide 74 by 16, you have 4, remainder 10, which implies A in base 16. Divide 4 by 16, you have 0, remainder 4. So our answer is 4AC, not 4, 10, 12. You use letters to represent digit 10 to 15 in base 16. We take the fractional part and you convert it to a decimal fraction. This is a common or ordinary fraction. When you convert to decimal, you have 0.6953125. So you multiply this number continuously by 16 until the last result is 0. Remember, this is the part that you multiply and you keep the remainder under 0. If you multiply that part by 16, you have this result. The remainder is 11, which you keep here. You multiply the second result by 16, you have 0 all through, and the remainder is 2. You keep the 2 there, then everything is 0 now. You stop multiplication. 2 11 implies 2b, implies 2b. So if you put everything together, 1196 whole number, 178 over 256, this result is for the whole number part 4AC, point 2b for the fractional part. You have successfully converted this number in base 10 to base 16. Note what happens here. You know, I'm supposed to write this one as 0.B2. Most times when we are writing a letter and a number, we give preference to the number first. So B2 is also written as 2B. That is what happened. So while we replace this 0, that is the whole number part, you replace it with 1196, whose value is 4AC. 0.2b. Are you following? Example 34, you have 82/5 in base 10 to base 16. So let's convert this improper fraction to a mixed fraction in this form, where we convert the whole number part to base 6, not 16, to base 6. We convert the whole number part to base 6 by continuous long division, and we convert the fractional part to base 6 by continuous multiplication as well, until the last digit is 0 or you observe a repeating pattern. For 16, you divide it by 6 until the quotient is 0. So you have 16, you have a base 6 column and remainder. Divide 16 by 6, you have 2, remainder 4. Divide 2 by 6, you have 0, remainder 2. You record the answer upward and you have 2, 4. 2/5, when converted to decimal fraction, you have 0.2. So you multiply 0.2, precisely the digit after the point, by 6, and you record what is left. So 6 times 4 is 24. You put down 4, a single digit, and you carry 2. You multiply 4 by 6 again, you have another 24. You put down 4 and you record the remainder 2. So if you continue in this manner, you keep on having 4, 4, 4, 4, 4. So what we do, you stop the multiplication process and you record your answer as 0.22. But you know that 0 point is the whole number part that you replace by 24. So therefore 82/5 base 10 is equal to 24.22 in base 6. Hello. End of lesson 6. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flip every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.